Hello everyone. Today in this video tutorial I am going to take a look over a new sensor that is ADS1100. Now to get a better view regarding this sensor, what we have to do is to log in to the website that is controleverything.com, and here we have to search on for this sensor and let's see what we got here. It's ADS1100 and here you can see it's a 16-bit one channel analog to digital converter, and also you can have some view over some of the features which are clearly visible on this very screen. And the plus point is there, you can purchase this sensor from this website from here. Now I will be interfacing this sensor ADS1100 with BeagleBone Black, and the platform I will be using is the C code. Now for the C language code, go to resource tab and here comes the C code sample. Now what we require next is to click over it, and after that you can download the code as zip file from here. Also, you can go to github.com directly, and from there the repository, there is Control Everything community, from where you can have your hands on the code, just like that. Now what we require next is to have a look over the hardware connections we need to set up, and let's have see what we got there. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen, and this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. The next thing we require is our sensor, that is ADS1100. Now this here is a connecting cable. Now this connecting cable is very useful in making connection with the sensor and the I2C Shield, and making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly to the I2C Shield, just like that. As we are done with all the connection setup, what do we require next is to have a look over the code. Now coming to the interfacing section, the first thing we require is to log into github.com, and here we have to search for the repository that is Control Everything community, and then here comes the sensor that is ADS1100, and this here is the C code. But before that, let's have a look over the instructions part, and here we have to set up the BeagleBone Black, and the respective instructions are provided on the link that is beaglebone.org. Please note it down carefully and do the setup exactly as per follows. And after that, we have to download the code in BeagleBone Black, and to compile the C program, as you can see, this is the command, and to run the C code, this is the command. Please note it down. Now get back to the C code. As you can see, it's a .c extension file, and in this code, which you can notice, we have included some of the libraries which you have to do it carefully. And in the void main function, we have created an I2C bus, and this function will check whether the bus is present or not. And in this part, this is a command which will check that the device is present and the address of the device, that is 0x48. Now in the writing section part, we are going to select configuration register, and we are going to send the continuous conversion mode 8 SPS 1 PGA, which confines for 0x0C, and here comes the writing section part. Now in the reading section part, we are going to read 2 bytes of data, which comprises of raw ADC, MSB and LSB, and here comes the conversion of the data, which we have followed as per the instructions which are provided in the data sheet for ADS1100. At the very end of our code, we have the output data to be displayed onto the screen, which is exactly the digital value of analog input. Now let's have a look over the working part. And for that, first of all, we have to copy this entire code. As you can see onto my screen, we have to copy this C code, and let's open up the terminal for the BeagleBone Black we have just connected, and here we have to create a new file. As you can see onto my screen. It's .c extension file, and here we have to paste the entire code, and after that we have to save it. And now for the compilation command, as you can see on my screen, this is the command, and to write the full command we have this, and let's see what we got here. And the compilation is in good hands. After that, for the working part we have this, and let's see what we got here. This is the command for the build, and we have the digital value of analog input. It's a negative value which is almost constant to 0, but before I run the command again and again, it's coming constant because there is nothing connected among the terminals for this particular sensor. But instead, when I bring a battery, AA battery of 1.5 volt source, as I connect it among the two terminal ends, and I run the build command to run it, and we have the digital value of analog input, which is a value of some magnitude, which is 5601, and when I run again and again, we have a value which is exactly similar. There is not a much significant change, which means the sensor responds in its particular way, and it works in this way. So this is how the sensor responds. Now what do we require next is to have a look over the working applications and some of its more prominent features. So let's have a look over that also. The ADS1100 is a precision, continuously self-calibrating analog to digital converter with differential inputs and up to 16-bit of resolution. The ADS1100 uses an I2C compatible serial interface and operates from a single power supply ranging from 2.7 volt to 5.5 volt. The ADS1100 is designed for applications like portable instrumentation, industrial process control, smart transmitters, factory automation, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.